Hey everybody, I'm going to show you something interesting here. This is my ground-to-ground harvester, and let me put a little bit of light on here for you for a minute. It's the same circuit here as the radiant air circuit, except there's a twist. I am using the house ground, as you see here, this clip on the overhead light. And I'll shut that off in a minute to show you, but this is my antenna connection, the house ground. And now what appears to be happening is the earth ground, which is on the opposite side of the circuit, right here. I'm actually having it on the what would have normally been the positive output. I've got my earth ground going there. And when I measure there, I get positive 3.7 volts. So there is a difference of potential between the earth, my ground rod outside, and the house mains grounding. About 3 to 5 volts max. And I can show you that here on the DC meter. 3.83, it's climbing a little bit. 3 to 5 depending on what all I got hooked up here. And we saw before with the LED that goes boop when I hook it up. But the system has enough sustainability that this LED remains lit. I can hook it up to the rotary over here and get it going faster. It chops it pretty good. As you see, if you give it just a quick second long to charge longer, it's even brighter. There's more of a discharge. So, difference of potential between two different places of the earth. One thing I have noticed is that it is also sensitive to any line noise on the house mains. Flicking fluorescent lights on and off causes a surge in voltage, causes the LED to go brighter. Plugging in a motor over here on the receptacle circuit, which, you know, well, I guess it's the same circuit on the bench here as the overhead light where this is hooked to, causes a back spike in there and makes the LED light up brighter. It's a line noise harvesting device as well as being able to work with this difference of potential here that is inducing, I must say, maybe 5 milliamps, 10 milliamps. What's it take to light an LED? Maybe 20. It's not full brightness. It is when we chop it. Oh, there we go. And it doesn't take long at all to jump back up there. You see the voltage goes to 3.5 pretty quick. I'm going to chop it and it's going to drop down. You see the sustained voltage shorted directly across the LED is 1.6 volts. And we get up to 3.5 with it going, and the LED stays lit. So, it's interesting. Can't really get a good look at anything on the scope with it for some reason, no matter where I try. All I see is a dirty AC signal that looks like it's being picked up from somewhere. Here I can show you when I'm flicking my overhead light on. You see the LED flickers a bit, it surges. When I'm holding in the starting capacitor, it's got a push button for the start capacitor to charge up. You can see when that's happening, the LED flickers. It also, it also gets really, really bright, and it absorbs up to 15, 20 volts when I fire up this bad boy over here. You see the LED gets really bright. So it's absorbing that through ground as well. Open voltage is 8